Flash models are supposed to be cheap and fast, but not smart. Step 3.7 Flash just challenged that rule. A 198 billion parameter sparse mixture of experts model with 11 billion active parameters per token, multimodal from the ground up. And it scored 56.3% on SWE-Bench Pro, ahead of DeepSeek V4 Flash, ahead of Gemini 3.5 Flash. What makes this interesting isn't just the benchmark number, it's the category. Step 3.7 Flash is positioned as a Flash tier model, competing with DeepSeek V4 Flash, Gemini 3.5 Flash, and similar efficient models. And on the agentic tasks that matter for production pipelines, it consistently leads that tier. This video is the complete picture. What it actually is, how the architecture works, the real benchmark numbers with context, a live generative demo, what it gets right, what it doesn't, how much it costs, and whether it belongs in your stack. Real data only, no fabricated metrics. Step 3.7 Flash is a sparse mixture of experts vision language model from StepFun, the Beijing-based lab behind the Step 1, Step 2, and now Step 3 model family. Total parameters 196 billion for the language backbone, plus a 1.8 billion vision transformer projector. Active per token roughly 11 billion. The architecture is sparse, not all parameters fire for every token. At inference time, you're activating about 11 billion out of nearly 200 billion. That's how you get 400 tokens per second throughput while keeping quality competitive with much larger dense models. Efficiency without the usual quality trade-off. Context window 256,000 tokens. That's a full novel, a large code base, or a dense research corpus held in memory at once. Precision options BF16, FP32, FP8, and NVFP4, 3 selectable reasoning levels, low, medium, and high. Let you trade speed against depth per request. Speculative decoding ships out of the box. The vllm configuration uses MTP with 3 speculative tokens. The SGLang configuration uses eagle with 3 steps. For production deployments where latency is a real constraint, this is configured in the launch command by default. You don't have to add it yourself. The model is designed to work inside real agent frameworks. StepFun's internal benchmark stack explicitly tests Hermes agent, OpenClaw, KiloCode, Claude Code, and Roo Code as orchestrators on their internal SWE benchmark with the Hermes framework. Step 3.7 Flash averages 67.5%, within 4 points of Claude Code at 71.5. The benchmarks StepFun chose are deliberately agentic. SWE-Bench, Terminal Bench, ClawEval, BrowseComp, Toolathlon, HLE with tools, not fill in the blank, not pattern matching. These are tasks with real environments, real execution, and real pass-fail verdicts. The comparison set includes DeepSeek V4 Flash, Gemini 3.5 Flash, GPT 5.5, and Claude Opus 4.7. The honest framing. Flash models run against frontier models on the same benchmarks. Claude Opus 4.7 scores significantly higher on almost everything. It has more active parameters and more compute, but it also costs roughly 9 times more per task. The real question is what you get per dollar in production. SWE-Bench Pro is the hardest mainstream coding benchmark. Multi-file, multi-repo, real pull request, real test suites. Step 3.7 Flash scores 56.3%. DeepSeek V4 Flash 55.6, Gemini 3.5 Flash 55.1, GPT 5.5 58.6, Claude Opus 4.7 64.3. The generational improvement is real. Step 3.5 Flash scored 51.3 on the same benchmark. Step 3.7 Flash scores 56.3. That's 5 percentage points in a single generation. The rate of improvement in agentic coding from efficient models is faster than many people expected. Terminal Bench 2.1 test shell level system tasks. Controlling a terminal, writing scripts, navigating file systems under real constraints. Step 3.7 Flash scores 59.5%. DeepSeek scores 62. Gemini 3.5 Flash 76.2, GPT 5.5 82.7. This is the benchmark where the Flash ceiling shows. The multi-turn coding picture is more competitive. On SWE-MTLG, which tests multi-turn long horizon coding, Step 3.7 Flash scores 72.4%. SWE-Bench verified 76.5. These are strong numbers. Terminal bench shows the ceiling. The multi-turn benchmarks reveal real depth in code reasoning. The vision component is not a wrapper. It's a 1.8 billion parameter vision transformer co-trained with the language backbone. Step 3.7 Flash combines visual perception with Python tools. It can crop, zoom, and draw bounding boxes as part of a reasoning chain. Not just describe an image, act on it. Simple VQA with web search 79.2%, effectively tied with GPT 5.5 at 79.1, and ahead of Kimi K2.6 at 78.2, V-star benchmark with Python tools. 95.3%, this is real visual processing, grounding, retrieval, and manipulation, not just image captioning. World VQA, which tests visual world knowledge grounding, 58.1%. That beat GPT 5.5 at 54.6 and Kimi K26 at 56%. For agents that need to understand what something is and what it means in the real world from a visual input, this is a genuine strength. Android daily measures phone-level GUI automation on real tasks. Step 3.7 Flash scores 61.87%, ahead of Kimi K26 at 53.36 and GLM-5V Turbo at 51.68. Gemini 3 Flash edges it slightly at 63.2 mobile agent. Use cases are legitimate here. HLE with tools is humanity's last exam. Run with web search and code execution enabled. The model scores 47.2%. Step 3.5 Flash scored 35.7 on the same task. That's an 11.5 point jump in one generation on the hardest knowledge evaluation benchmark that currently exists. BrowseComp tests multi-source web research, finding answers that require planning, cross-referencing, and synthesis across many pages. Step 3.7 Flash, 75.8%. DeepSeek V4 Flash, 73.2. Claude Opus 4.7, 79.3. GPT 5.5, 90.1. Solid for a Flash model, not frontier. ClawEval 1.1 is where it leads. This benchmark tests instruction adherence, tool call reliability, and resistance to adversarial traps inside complex pipelines. Step 3.7 Flash scores 67.1%. DeepSeek V4 Flash 57.8. That's a 9-point lead on practical workflow integrity. The thing that actually breaks production agents. Deep Search QA F1 score 92.8%. Accuracy 81.7. These place it at or near the top on search integrated reasoning. Web search isn't bolted onto this model. It's a native part of how it reasons. That architectural decision shows up consistently across the search and research benchmarks. Let me show you something it can generate. I gave Step 3.7 Flash a single prompt. Write a neural particle simulation. Hundreds of particles that flock and repel like neurons firing, running in a browser with zero external dependencies. This is what it produced in one shot. No edits. Amber particles with glow trails. Mutual attraction and repulsion, all physics driven by a single JavaScript file. You're watching it run in real time. The particles self-organize based on distance and velocity. The prompt was about 20 words. The model wrote the complete physics engine and renderer from scratch. Now let's take it to Hermes, the open agent framework where I test models in real conditions with real tools against tasks that fail most systems. This is where benchmarks meet actual execution. Let's install Hermes agent on our Windows. I copy this command and then I go to PowerShell, and here I just paste it in, and this should install your Hermes agent. You already have Hermes configured, and then we say inference providers, and we are definitely looking at Nose Hermes. I want Nose Hermes here. I just say 1 and press enter. This will help me log on to this portal.nosehermes.com. I've created an account, free account, so I have $0 here, but this will be super useful. So I'm going to click on the free account here, and I'm already logged in as prompt engineer here, you can see. So free, and subscribe and connect. It's processing. So now your Hermes agent is connected. You can go back and you can see the login is successful here. And now we see on the free models that we have here. So one of the models that we are talking about right now is this StepFun and Step 3.7 Flash. And this is free, as you can see. Let's use that model to confirm. And then for the terminal backend, again, leave it just as it is, local. Messaging platforms, let's leave it now. We don't need it. If it's configured, then it will be configured. Already configured. Telegram, I've used to Telegram earlier. But install a gateway as a the schedule task service runs in background right now, no, and configure CLI, it's okay, and just say enter, just say 6 here for done, and tool availability. Would you like to start the gateway now? I can say yes, and restart your terminal for path changes to take effect. And I can see all these paths that go basically into C users, username, app data, local Hermes, and I can just close this. I can open up PowerShell again, and now I can say Hermes. So that has started up. We can see the available tools. I guess you already know this, and we have these MCP servers here, we have available skills here, and I can see the model that we are using is Step 3.7 Flash free, and it's ready for inference. Let's go ahead and see if it's useful. Which model are you using? And you can see it's brainstorming, fingers crossed, and see I'm running on StepFun, Step 3.7 Flash free, served through the nose provider. So you can see the context length is 256, out of which 40k has been used, okay, with just one single command. Now I can say what is my name, and I can see the output here. Your name is prompt engineer 48, and because I've already used Hermes, it already has that memory. Now for testing out Step 3.7 Flash, what you can do is, what I normally would like to do is I go to their page that introduces Step 3.7 Flash, and then look at the benchmarks that they're saying that it's excellent on, and you can see that Agentic coding benchmark, it has this, and then we have the multimodal benchmark here, and the general agent benchmark here. So why not ask Step 3.7 Flash to create a presentation on itself? That would be nice. So I copy this, and then I say Step 3.7, and I paste it here, and then I say, can you make a 3-page HTML presentation on this language model? Let's send this over. So as a matter of fact, you can see the first command took about 40k tokens, and the next command doesn't take that 40k token, because at the start of each run or each session, we need to load in some different files, for example the soul.md and the user.md and the skills, the list of skills only. So it has all those things that has to be loaded up, and therefore that context is being used. And now we can see that it's preparing the web extract, and it's downloading things from Step 3.7 Flash, and then you'll see the output here. And you can see that it's done. So it wrote a presentation into this folder. So let's go to that folder, see users, and then you can see this presentation. Let's open this up, and I think it's really great. It's really great. So we see Step 3.7 Flash, 196 billion total parameters, agentic depth, what it does, and basically it's pretty good. Let's go ahead and test out the capabilities related to Hermes. Can you check my cron jobs? So it's preparing the cron jobs, cron listing, and you can see I have one cron job. Say the message hello to the Telegram ID. Once in 3 minutes, repeats forever. Really? So we can just stop this. Okay, the cron job has been removed now, and now with this new Hermes, you can see when you press slash, we have all these things that you can do. We can start a new session, you can reset, we can clear, redraw, history, save, hand off to this session to a different session here. You can branch, fork, compress this conversation, and then you can see we can start up a new agent. You can steer, means that inject in message after the next tool call without interrupting the ongoing process. You can set a standing goal. Hermes works on turning until it's achieved. So, and then I say goal, write me an animation of a tree blossoming with green leaves and let's say and pink flowers. Let's give it for fun. And I can see that what it does when we say goal, after each turn a judge model will check if the goal is done, and then Hermes keeps working until it is done. Then we pause, we clear it, or a budget is exhausted. So until then it goes ahead and does the job. Basically it's done. So it created a blossoming tree.html. Open it on any browser and watch a tree grow from bare branch. Let's go ahead and watch this. So this is a blossoming tree. Okay. That's really amazing. It's not just blossoming, it's a storm. There is a storm, or there is some ghost here who is shaking the tree, and we have the flowers going in random directions, and it's really amazing. I really like the feel, I really like the concept. We didn't explicitly mention it to blossom in a certain way or to start from the branch and then go ahead. So this is what it thinks, and I would say this is really amazing. And you can see the small plants here as well. You can see the stars blinking as well. We have the moon as well. That's a really good one. one. I really like it. Pricing through the StepFun API, 20 cents per million tokens for input on a cache miss, 4 cents per million on a cache hit, $1.15 per million for output. For context, Claude Opus 4.6 input is $15 per million tokens. The gap is not small. StepFun benchmarks an advisor mode pipeline where Step 3.7 Flash handles most tasks and escalates complex ones. Their measurement, 19 cents per task. Claude Opus 4.6 handling equivalent tasks, $1.76 per task. That's roughly 1/9. The cost for about 97% of the performance on that specific task set. For access, StepFun API at platform.stepfun.ai. Globally, Open Router, NVIDIA NIM, and upcoming availability on Deep Infra, Fireworks AI, and Modal. The weights are on Hugging Face under Apache 2.0. You can download them, run locally, fine-tune, or deploy in a private environment. Local deployment is real, not theoretical. vllm has a custom Docker image for this model. SGLang has a dedicated container. llama.cpp has a Step 3.7 branch with gguf quantization. All three support native tool calling and the step reasoning parser. The infrastructure is already built and maintained. The hardware floor is significant. Minimum 120 gigabytes of unified memory. That means an AMD Ryzen AI Max Plus 395, a Mac Studio or MacBook Pro with 128 gigabytes, or an NVIDIA DGX station at Q4KS quantization. The ggf file is 111.5 gigabytes. For enterprise deployment, NVIDIA NIM microservices support on-prem, hybrid, and cloud. NVIDIA NeMo handles customization with Megatron Core. The model also works with NVIDIA speculative decoding and expert parallel inference at scale. This is the full enterprise deployment stack, not just waits on a download page. 4 things Step 3.7 Flash genuinely does well. First, ClawEval performance. 67.1% on workflow integrity and instruction adherence. First place in the Flash comparison. DeepSeek V4 Flash scores 57.8 on the same test. That 9-point gap matters for production agent pipelines with complex policy constraints. Second, native multimodal tool use, not image captioning, image manipulation via Python tools, combined with non-visual tool calls in the same reasoning chain. The V-star score of 95.3 demonstrates this works. For workflows that process screenshots, documents, and charts, this is a real capability distinction. Third, search is built in, not bolted on. Deep Search QA accuracy of 81.7 and F1 of 92.8 place it near the top on search integrated reasoning. World VQA at 58.1 beats GPT 5.5 on the same task. Search as a native capability is the architectural decision that made the difference. Fourth, open weights under Apache 2.0 with real self-hosting infrastructure, vllm, SGLang, llama.cpp, gguf quantization, NVIDIA NIM. If you need a multimodal agentic model running in your own infrastructure, private, air-gapped, or on-prem, this is one of the few that ships the complete tooling to actually do it. 4 honest weaknesses. First, Terminal Bench 2.1 at 59.5%, Gemini 3.5 Flash scores 76.2, GPT 5.5 82.7. When your agent needs to operate complex shell environments with multi-step system tasks, more specialized or larger models have a real and significant edge here. Second, the hardware floor for local deployment. 120 gigabytes of unified memory minimum. A Mac Studio with 128 gigabytes starts around $3,000. An AMD Ryzen AI Max Plus laptop is a separate investment category entirely. This is not a model you run on your current workstation, planned for dedicated hardware. Third, Toolathlon at 49.5%. This benchmark tests raw tool interaction breadth, reliable use of diverse APIs across many tool families. Claude Opus 4.7 scores 65.4. That's a 16-point gap. In workflows requiring wide tool coverage across many different APIs, frontier models still lead by a meaningful margin. Fourth, the full agentic stack is cloud API-dependent advisor mode. Search integration and the multi-agent routing that drives the cost efficiency claims, those live in the hosted stack. Local deployment gives you the base model. The full orchestration layer requires the API endpoint. Step 3.7 Flash is built for teams running agents at scale. If you're paying per token token for Claude or GPT, 5.5 on thousands of agentic tasks per day, and most of those tasks fall within Flash capability range. The price performance math changes significantly at volume. It's also worth attention for enterprise teams building private multimodal pipelines. Apache 2.0 weights, real inference framework support, genuine image tool integration, and benchmark results showing reliable instruction adherence. These put it in a small category of models that can run complex agentic workflows on your own infrastructure. Everything in this video uses real benchmark data from StepFun's published blog and the Hugging Face model card. No numbers were fabricated. The Hermes testing segment will be linked in the description. Once it's live, if you want to test it yourself, the API is at platform.stepfun.ai. If you found this useful, like and subscribe. I'm Prompt Engineer 48. See you in the next one.